Welcome students. Yesterday's class we have discussed about algorithm design techniques, that is specification, abstraction, composition and decomposition. Today we are going to discuss in a detailed manner about the specification. Specification means we have to follow some steps to solve a problem. That steps should be followed in an algorithmic manner. For solving the problem, we should state the problem clearly and we have to specify the input for the problem and what is the desired output for that problem. To design an algorithm for solving a problem, the properties of the given input and properties of the desired output should be known. And the goal of the algorithm is to establish the relationship between the input and the desired output. In this picture, we clearly understand algorithm is established or between a relation between the input and the output. Let us see the example. Let P be the required property of the input and Q be the property of the desired output. Here we are writing the specification as algorithm name of inputs hyphen inputs colon P hyphen outputs colon Q. The double slash indicates that the rest of the line is a command, and this line should starts with double slash always. And let us see the example for the specification. We are going to write the specification for an algorithm to compute a quotient and the remainder after dividing an integer a by another integer b. That is divide of 22, 5. So what will be the remainder? That is 4, quotient will be 4, 2 and 15, 3. (22, 5). The quotient will be 4 and the remainder will be 2. And 15, 3, that is 15 divided by 3. The quotient will be 5 and the remainder will be 0. For this purpose, we are going to use these properties for writing the specification. A should be an integer and B should not be 0. And remainder is meaningful only for the integer division. That is, for this we have to write the properties. Input A is an integer and B not equal to 0. And the next concept about the specification is two outputs Q, quotient and remainder R should satisfy the property. And the remainder R should be less than the divisor B. R should be less than B. So by the combination of these two requirements, we get a specification A equal to Q cross B plus R and 0 less than R less than B. So we can specify this relation for dividing A comma B as integer, as an A is an integer and B not equal to 0. We are getting the desired output as A and 0 less than equal to or less than B. And next one more example it is given in your book. Just you can go through the example. And next one is abstraction. Before entering into the definition for the abstraction, we are going to discuss about an example. To ride a bicycle, the user should know only the basic features of the bicycle. They don't want to know about all the details of the bicycle. That is not necessary for the rider. For example, pedal, handlebar, brakes and bell. These are the four essential features. This alone can rider know. The irrelevant features of the bicycle, no need. Like that, for the problem also, we can have a lot of details. Only the several details of the problem can known to the programmer. The other irrelevant details will not be necessary for solving the problem. For example, map. Suppose we are designing a map software or an app. Google Map is there, you know. In that map, the basic road map is necessary for the rider. No need of other details about the hills or what are all the shops available and other details. No need for the map. Only the road is enough. So this is the example for the abstraction. And next one is state. State is a basic and important abstraction. For the computational process, it starts with the initial state and it ends with the final state. Each and everything we need an initial state and final state. And next we will move on to assignment statement. Assignment statement means there may be a variable. It is variable means it is a named box to store a value. Here they have given the syntax variable colon equal to value. That is m equal to 2. So the value 2 will be stored in the variable m. And by seeing this we can understand the values will be stored. But if you are giving the expression m equal to m plus 3, it will not be accepted as an storing the value. It is for calculating, it is variable equal to expression m plus 3. So 2 plus 3, 5. Then the 5 will be stored in m. So 2 plus 3 equal to 5. That is the 5 will be stored in m. So v equal to e. V is an variable. E is an expression. That is v1, v2, v3 equal to e1, e2, e3. The left side is an comma separated list of variables and the right side is an comma separated list of expressions. For this, let us see an example. M, n equal to 2, 5. M, n equal to question mark. So what is the expression for m is m plus 3 and the expression for n is n minus 1. Now what will be the value of m and n? M plus 3, that is already we know m is 2. So 2 plus 3, 5. And what is n? 5. Minus 1 is given. So 5 minus 1, 4. So the output for this one is 2 plus 3, 5 and 5 minus 1, 4. So this will be the output of this example. In this manner, we can store the values in the variable and also we can give the expression for the variables. If you are storing the values means variable equal to value. If you are giving an expression means variable equal to expression. So in today's class, we have discussed about the specification, abstraction and the assignment statement. Up to this, we have completed the 6th chapter. In next class, let us see about the 7th chapter. Thank you.